Hey programmers, welcome back to day 12 of the Advent of Code. So let's take a look at today's input file. So it's going to look something like this. What we have to do in this problem is really work around navigating a ship, and we're going to have a few different types of commands. So we're going to have a first set of commands that just give us the cardinal directions of north, south, east, west, and we're also going to be given a number along with those commands. What we should do is just move the ship in that direction exactly that number of units. In addition to that, we have more of a rotation-based navigation instruction as well. We're going to be given F to mean move forward based on the current direction we're facing, as well as the ability to rotate to the left or right a certain number of degrees. So let's trace through how this works. Our ship's going to begin at some origin, we'll call it 0, 0, and by the end what we want to do is figure out exactly how far the ship has moved. So we're going to begin the ship right here. And we should also know that by default, this ship faces toward the east. Cool. So if I interpret my very first command over here, it says go forward 10 spaces, and that would be based in my current direction, right? So that means I move 10 units to the east, like this. Cool. At this point, I can move to my next command, which just says go north 3 units. And so what this command is saying is I should move my ship up 3 units north, irrespective of the direction it's facing right now, right? So although my ship is facing east, N3 just means go to the north exactly 3 units. So it ends up looking like this. Now I have F7, which means move forward based on my current direction. So that means 7 toward the east. Then here I have my first rotation command, right? So with a rotation command, if it's R, that means rotate clockwise. If it's L, that means rotate counterclockwise. So this one says rotate the direction that your ship is facing 90 degrees clockwise. So it ends up looking like this. And on my next command, now I have another forward command, and now that I'm pointing to the south, technically that would mean moving 11 units to the south. So I end up in this final position. So in the long run, this problem has us calculate how far the ship moved from our kind of base position. And so if we consider 0, 0 as our origin, then this new position we're at would basically be 17, 8. And in the long run, we want to take that coordinate and actually just add up the absolute value of its x and y coordinate, and that'll give us the answer we should return back to the Advent of Code. So that process doesn't seem too difficult. Let's go ahead and code it up. So here I have my input file. Let's go ahead and start parsing our data out of these. So I have my classic read lines helper function. Let's just see what each of those lines looks like as we go. Give this a run. This is my part 1. Yeah, so it's just an array of each of those strings. So we're going to have, in my opinion, like 2 types of different commands. In part 1, I have the commands that just do the north, south, east, west, which are pretty easy. And then I also have the rotation and forward commands. So let's start to at least grab the letter part as well as the number part from each of these commands. So I think it would be awesome if we created a maybe parse command function that takes in one of those strings. I'll call them one of the lines. And what it should do, just return an object where I have a nice, we'll say, type property, which would be the letter, as well as the value, which would be the number part, right? So what I can do is I can say, no matter what, it looks like always the letter part is always just one letter. So I can say const, say type equals line at index 0. And then the rest of it should just be the number part. Notice that sometimes numbers can be 1 digit, or 2 digits, or even 3 digits, right? So what I'll say is const value equals line.slice, starting after the first character. And I want to actually convert this into a number. So it should be as simple as calling the number static method on that. Nice. And let me now just return this stuff. So I'll return an object containing type and value. So that'll just give me some nice objects that I can operate on. So let me print out what happens when I map over these lines. So I'll say lines.map for every line, parse it as a command, and I'll save that to my commands. So I'll just be an array of those, right? See how that looks. Give that a shot. Cool. You could even do a console.table when we kind of take a look at these, since they're objects that all have the same properties, right? Cool. So that looks much better. There we have our properties at the top. This is really long. Yeah, we have our type and value. Nice. So why don't we maybe break off into some helper functions? I'm going to maybe consume all of the north, south, east, west commands separately from the actual rotating commands. Because when it comes to like the north, south, east, west commands, it's pretty much just a matter of like adding things up. You can think of north as going positive in like the y direction and south going negative in the y direction. So we'll just create a function to do that. Maybe I'll actually separate these out. So I'll create my const cardinal commands. So those are the north, south, east, west ones. So I can do maybe commands dot filter. I want all the ones that have a type of north, south, east, or west, right? So for every, we'll say command over here, maybe I'll create a nice set to kind of check things. So I'll say const cardinals equals maybe just a new set. That set just gives me slightly faster lookup, constant time always, even though this set always has just 4 elements, right? Just simply north, south, east, and west. East and west. Fix this up. Cool. And now when I want to pluck out just the cardinal commands, then I'll just check, hey, does my cardinals, make sure I spell that right, do my cardinals have that type? So command dot type. Nice. And along with that, I guess we'll also want to grab all of the rotation commands separately. So I kind of just flip this around. I'll say my rotation commands will just be the opposite, right? So they are not cardinals. Probably could, write this in a single loop, but this should still give me O of n just for these 2 lines, right? So let me just console.log what my cardinal commands look like. Cardinal commands. And I'll even console table these. So I should only have the directions now. Cool, so I don't have any of the rotation moves or any of that stuff. And yeah, let's keep it rolling. So I'll create a function now to calculate the cardinal distance. So I'll say const calc cardinal. And I'll go ahead and just take in commands, which is really in particular just the commands with north, south, east, west, right? So what we want to do is figure out how far our ship ends up from its original starting point, right? So I'm going to consider its original starting point as maybe some ship object, and it begins at the origin. We'll call it x0, y0. Nice. Then from here, I just want to look at every single command. So I'll say for let command of commands. And as I'm iterating through, I know it's going to be a command of this shape, right? So I'm going to destructure out of it. We'll say the type as well as the number value, right? So that'll be my command. And now I can just check some, really straightforward conditional logic to do some arithmetic on the x and y components of my ship as I iterate through these commands, right? So for example, one of them would be, hey, if my type equals north, then to me, I'll consider that the positive y direction. So what I'll say is for my ship.y should add into it your value. Right? Notice that in the context of our list of cardinal commands, the values are always positive, right? It's really the direction that kind of determines the sign, right? So if north is +3, then south should be like a -4 to that y component, right? So I'm just going to write a very similar expression for all of these. So here I have my conditionals. Notice that I have different signs for some of them. And I think at this point, all I'd want to do is just return what my final ship looks like. So just giving back the x and y, which would represent the position relative from the starting point, which I consider 0, 0. So that's looking pretty good. Let's say we actually ran that function. So we'll do console.log. Let's just print out what happens when we call calc cardinal on those cardinal commands. So we should get like a partial result here, just an object. Nice, so apparently if I consume all of the directional commands, I get this sort of delta on my position. So now I want to create a very similar function, but using the rotation notation now. So let's do it. Let's say I create up here our const, we'll say calc rotation. Taking my commands once more, but I'm assuming that they're always the L, R, or F commands, right? Left, right rotations, as well as moving forward. And they tell me that from the get-go that our ship starts facing a particular direction, starts facing the east. So I need to keep that in mind. So I'm going to begin my ship maybe in the same place. So 0, 0. But I also need, some state to determine like what direction I'm facing. So what I'll do is I'll also add another property to my ship just for the sake of calculating it, and I'll call it let's say angle. The angle starts in the east, but I'm going to use just the actual number to represent that. So I'm going to consider that 90 degrees. So I guess we should talk about what this number refers to. So we know that in general, your kind of directions look something like this. They go, some comments here. We have north over here, then we have east over here, then we have south over here, and then west to the left. Cool. And so I'm going to kind of think about these as if they're form a circle, right? And I know that my angles are always going to be at right angles. So I'm going to consider north as 0 and then east as 90 degrees. That means that south would be at 180 degrees and then west would be at 270 degrees, sort of like this. Let me clean this up. Notice that a full rotation of the circle brings you back to where you started, right? So if I was north and I rotated 360 degrees, I would be back at north, which is 0. Cool. So I'm just using some angles here. That way it's kind of already compatible with the shape of our input data, right? Remember, that's always going to be some number angles. So now let's start iterating through our commands. I'll take this for loop. And I do want to still destructure out the properties from it. So the type and value. Cool. So now let me start by checking if it's a actual rotation command. So maybe if the type, we'll say equals in L or in R. Remember, that kind of determines whether it's counterclockwise or clockwise, right? I think I'll actually want to separate these, right? Because in one scenario, I'm probably going to negate the angle, and in the other scenario, probably not going to negate the angle. So I'll do it like this instead. So I think the right-handed rotation is a little easier to think about because I think I can keep the sign of the angle positive, right? So here's what I'll do. I know that I want to add something to ship.angle, so I'll say ship.angle. I'm going to increase it by, let's say, this value, right? However, if I just did that, that wouldn't really ensure that our angle was within 360 degrees, which it should be to kind of keep it convenient, right? So let's say that I was at east 90 degrees at the start, which is kind of literally what happens in my code. And if I rotated, let's say 180 degrees, then I should be at 270, right? So I'm doing 90 plus 180, and I'm at 270 now, which is good. But if now I said, all right, maybe I start at 90 degrees, but now I rotate the full 270, 90 plus 270 gives me 360, which should have the effect of kind of bringing me back to 0, right? So a nice trick I can use here is, as I increase the angle of that ship, I'm going to actually also mod it by a certain quantity. So maybe I'll say, hey, ship angle is going to equal the current ship angle plus the value, but also I should mod it just by 360. Something like this. So let's see how this works so far. It's very partial, but maybe after every command, I'll just console.log what the ship looks like. Just a quick debug, right? And then I'll just go ahead and call calc rotation. Looks like I spelled it wrong too. Let's fix that. Rotation. And I'll pass it maybe just one command for now. So I'll say, hey, rotate to the right. Let's say 180 degrees. So it look like this. So actually an object of type right and then val of 180. Cool. And what I expect to happen is my ship should be at 270 degrees as its angle, right? So let's see what this gives so far. We'll do node part 1. Cool. So I'm looking at this very first line of output, right? So yeah, it's at 270, which is good to go. And now if I actually rotate it from 90 around 270 more degrees, I don't want to see a 360. I want to see a 0, right? Cool. So that's looking pretty sharp. Let's go ahead and now finesse the logic for our counterclockwise rotation, right? So we're still going to manipulate the ship angle, but this time we want to move in the opposite direction. So we'd be tempted to write maybe like ship angle like minus the value, kind of going in the opposite direction. You have to kind of watch out here though, right? So let's say that I'm at starting at 90 as always, but now I rotate to the left. And if I rotate 90 degrees to the left, I think that seems pretty reasonable out the gate, right? So that just brings me back to 0. But then let's say I actually rotated negative, or not negative, but rather 180 degrees, right? So if I rotate to the left 180 degrees, that should bring me to this 270 over here. So let's see what that looks like right now. Right, so here I get negative 90, which is technically like just logically correct, but to make my code cleaner later on, it would be nice if we consider negative 90 as really just a 270. That way I don't have too many like values to check. So I always want to keep my angle in the range of 0 up to but not including 360, right? So we just have to think of some math that we can use here. So what we could do is just actually take this quantity, and I'm just going to increase the entire thing by 360. So if you think about what this does, adding 360 into any angle doesn't change it because it's just going around in a circle. But what it can do is make this angle now a positive interpretation, right? And then along with that, I'll just also be sure to, let's say, mod it by 360 for the same reason as before, right? I want to make sure that doesn't go over 360, right? So what effect does this do? Well, let's say that I rotate my angle counterclockwise. That could give me a negative quantity. But if I increase that by 360, now it's definitely positive. And in addition to that, I want to make sure it still falls below 360. So let's see what this rotation command does now. So I get 270, which is correct, right? If I started at 90 over here and I rotate 270 left, or 180 left rather, then I end up at 270, which is good to go. Nice. Now from here, we just want to consume our only other command, which would be about the forward command, right? So if we hit this else statement, then we definitely know it's a forward command, and we just want to move forward that many spaces dependent on our direction. And I know that my directions are just these numbers 0, 90, 180, and 270. So for example, let's say if my current ship.angle, if that is 0, then you're moving technically north. So that should be a matter of just increasing the value by that. So I can literally, I guess, take this code, put it over here, right? And I can actually, I think, take all of this. I just have to change what each of them mean in terms of angles now, right? So I'm going to squeeze these over here. So south now means that your ship angle should have been, what was it, 180, right? Just going downward. Nice. And then east would have been 90. So I'll say ship.angle equals 90. And then west is just a nice 270, right? Same overall logic, just this more like radial way of kind of denoting how your ship moves. And by the end, I'll still return my ship. It kind of has some additional angle information. I'm not going to use that when I calculate my final answer though, but I'll just go ahead and return that. Cool. So that's looking pretty good. Now that gives me kind of the difference in XY for my rotation commands. Let's go ahead and see what both of these look like. So I'll do my calc rotation over here. So rotation. And then we'll want to combine them in a moment. Getting a little error here. I have a capital R. Let me fix that. Cool, so this is looking pretty good. So I'll go ahead and save these into some variables. I'll call this my const cardinal distance. Then I'll also save this as my const, we'll say rotation distance. And I can take out these over here. And now I just want to add up their respective components, right? So I can say something like, hey, cardinal distance dot x plus, I keep spelling rotation wrong, plus my rotation distance dot x. And I want to take the absolute value of that, right? So I'll say const, maybe delta x equals the math.abs of that. That's just given in the problem. They want the absolute value. So that really gives us the distance relative from our starting location. I'll do the same thing for delta y. So cardinal distance y and rotation distance y. And like they tell us, they just want to return the sum of that x and y delta, which now should be always positive because I already took the math.abs, and so when I add two positive numbers, it must stay as positive. Cool, so that was a lot of code. I wonder if this works. So if this is working, I should get the result 1,148. So let's give this a run. So we're on node, part 1. Nice, and there we have part 1. So nothing much to this problem, just some cool, I guess, rotational things. Kind of realizing that, hey, we can interpret the angles as also our directions, and the angles are always lying at, multiples of 90 degrees. Probably the most tedious thing was thinking about how we can make sure that our angle falls, within the range of 0 to 360 degrees. But with that, let's head back into the whiteboard and talk about part 2. So in part 2, we have to interpret the commands for navigation in a little more complicated way. We're still going to have a ship, but at any point in time, we can consider our ship's location as sort of a frame of reference, right? So our ship kind of begins at the origin, 0, 0, and kind of like before, we want to figure out exactly how far the ship is away from its starting point. And the way we actually navigate the ship now is by using some point that is relative to the ship right now, and we would call that our waypoint. So it would look something like this. In the problem, they tell us by default that the waypoint is going to be 10 units to the east and then 1 unit north. So it kind of looks like this. And so what the waypoint describes is exactly how many units in the x and y direction should the ship move on a single forward command. In other words, if I start interpreting my commands in my input, this one says F10. So that means move toward my waypoint 10 times. And how does that happen logically? Well, if I'm going to go to my waypoint 10 times, technically the waypoint moves with my ship as well, right? So imagine that I can basically just take 10 because I'm doing F10, and I multiply that by the x component of my waypoint as well as the y component. And that basically means I'm adding 100 and a 10 to my current ship's location, right? So just doing the addition there gives my ship now a position of 100, 10 relative to its original origin. And now when I move to the next command of my input, the north, south, east, west commands actually refer to moving or translating the waypoint. So this means move my waypoint up 3 units. So it ends up looking like this. Notice that that operation does not actually move the ship itself. It only moves the waypoint. But if I go to my next input, I have F7, so that means my ship should move toward the waypoint 7 times over. And to do that, like before, I can just multiply the components of my waypoint by 7. So now I can add that 70 and that 28 to the position of my ship, right? So now my ship is positioned at 170, 38. And here we have a pretty interesting operation next. Here we have R90. And so what this refers to now is manipulating the waypoint once again, but this time I rotate the waypoint clockwise 90 degrees, right, around the ship. So that kind of has this effect. Right? So now my waypoint, if I did that rotation around the origin, that would give me position 4, -10 for the waypoint. And when I proceed to the next input of my file, in the last one, I have F11, which means move toward the waypoint 11 times over. So I can use the same rule as always. I would do this addition into my current location. And that gives my ship a final position of 214, 72. And like before, we would just want to take that information and add them up, add their absolute values up, that is, and that would be my final result of 286. So most of part 2 seems pretty reasonable to code up, but maybe we're a little hesitant on how we can rotate the waypoint around the origin. Well, there are a few different ways you can think about that. It's pretty clear that from the input on the advent of code, it looks like the angle we always rotate is some multiple of 90, which in that case means that all of the rotations could be kind of understood as also a reflection across an axis, just like flipping the x and y coordinates and potentially negating them. But if we wanted to kind of swing around and rotate through any arbitrary angles, then we could just use some classic trig formulas, right? Using this formula, we can rotate any coordinate, x, y, around the origin at any given angle. And what's great is I already know that there are some built-in functions in JavaScript to perform the cosine and sine. So I think with that, we'll hop to it. So here in my part 2 file, I have much of the same code that we did in part 1, but we're going to have to create some new functions and overall refactor it. So now we're basically considering all commands together, kind of as one set. So I'm going to create a function. We'll just call it calc. I'm going to basically just merge a lot of the logic from calc cardinal and my previous calc rotation. So I'll say just calc, take in some commands. We still have this scenario where we want to track, the location of our ship. So I'll still have some object represent my ship, and I don't need to actually put the angle in here. However, now we also need to track a separate point, which would be our waypoint, which, if we're familiar with some math, kind of just boils down to like a vector, which tells us in what direction to move in. So my waypoint will also start at a very particular location. In the problem, they tell you that it must start 10 to the east and then 1 to the north. So this should be some valid seed data for my waypoint. All right, now that I have those two pieces of information, let me start iterating through every command. And we're going to start, I think, in much the same way. Still destructure your type and value. And let's start by just consuming the very easy commands. So to me, those are just these types of commands when they're north, south, east, west. Those just manipulate where the waypoint is translated to. So I'm going to refactor a little bit here. So I'm going to steal these conditionals from my calc function. But this time, they don't move this ship. They simply move the waypoint. So it should look something like this. Cool. So that handles those types of translations. We'll also need to handle now the actual rotations, which is pretty interesting. So here I'll add like an else if. Else if the type is going to be, let's say, an L, and something symmetric for a right-hand rotation. Cool. So what we'll do here is, like I said on the whiteboard, use some quick trig functions, nothing really too fancy. Let's say that I built some function, we'll say const, we'll say rotate point. And this is something that I don't have remembered offhand, something I did look up for this problem. I know I've covered it eventually, some point in my high school or college career. I'm going to take in some, we'll say, xy, as well as some, let's say, angle. What I want to do is rotate that xy coordinate around like the origin, or 0, 0, exactly by that angle. So we can calculate the new x point, so I'll say new x, by just doing some nice trig functions. Take your current value of x, multiply it by the cosine of the angle. And I should be using basically a math.cosine here. Cosine of the angle, and then you subtract it by the y times the sine of the angle. So this gives me the new x component. Cool. And something very similar for the y component. Maybe if we want, we should also wrap these up, maybe make it a little clearer. Now we can write the formula for our new y component, which would be basically a y times the cosine again, but then I add x times the sine. So I'm not going to go through like a deep dive on why sine and cosine are useful here. It is a math formula, but I'm just going to take it in stride. So this is looking good. XY, nice. Something that is kind of annoying about the built-in math.cosine, math.sine methods in JavaScript, and it's kind of maybe more or less just like a math tradition. Those take in not degrees, but they take in radians, right? So if you're unfamiliar, there are two main ways we can kind of interpret and measure angles. There's degrees, which there are 360 degrees within a circle, but there's also the radian kind of measurement. And so what we say in radians is a circle is 2 pi radians. And so we're going to create a function. We need to create a function to convert just degrees into radians, because I know that in our input file, they give us definitely degrees when they say things like 180 and 90, right? So we'll kind of do that. Let me create a quick function, and then we can actually test my rotate point. And I don't think we need any of these old functions, so I'll take them out while we're here. Keep my code clean. I think I'm done with these guys. And now I'll create something to convert. We'll say degrees to radians. And actually, before I forget, we should have returned some new object here. We'll say x is my new x, and then y is my new y. Nothing too fancy over there. So there's another formula for converting degrees to radians. So I'm going to take some degree amount. And it's just a matter of doing some manipulation with pi and stuff. This one's as simple as returning the degrees times the mathematical pi, right? So this is a nice constant. That's just the 3.14159 thing. I'm doing math.pi divided by 180. That should give me some nice results. I think I can even squish this into a nice inline arrow function. So we'll test the code. Well, console.log degree to radians, and let's say we gave it 90. So let's see what that gives back. So I should expect back, if a full 360 is 2 pi, then just a 90-degree turn would give me half pi, right? So like around 1.5 or something like that. So we'll run that, node part 2. Nice, so I get, yeah, that looks like about half pi. And I also wonder what happens if I kind of do it like this, if I say negative 90. How does it also affect it? We should just get different signs on that stuff. All right, so now let's start to add everything together. So we'll work on the right rotation first. So it should be pretty straightforward. All we need to do is call our rotate point. And I actually kind of wish we took it in an object because it's just convenient with the shape of waypoint already. So maybe I'll say over here, take in some point. And then I can destructure the x and y. So I say const x, y from the point. That should be already good to go. But now the upshot is, of course, on line 32, I can just pass in my waypoint as well as the angle that I want to rotate. So let's say I just give it my angle, which would be the value in this. Something that is kind of awkward about this is, in the kind of context of the problem, they say that when we do a right rotation, so with an R, that means we're rotating clockwise. However, in usually like the mathematical sense, and especially with like this formula, these formulas, whenever we actually rotate in that direction, we would consider it negative and not positive. So I actually kind of have to flip the sign of things here. So we'll do it like that. And that means for the L, I don't flip the sign, because traditionally in math, if we actually go counterclockwise in math, that actually means a positive angle rotation. So that should give me my new point. So I'll call that my new point, and I just actually want to reassign it back into my waypoint. So I should have made this a let. Then I'll say over here, my waypoint equals that thing, right? So I'm just reassigning it, which should be okay. And then for my left rotation, it'll just be the same thing, but again, like I just said, I don't negate over here. Cool, so this should be consuming most of our commands except the forward command, which is actually the one that performs the movement. So I'll just write an else here because I know there are no other different types. And so, like we said in the drawing, all we have to do is multiply the x and y components by the actual number of forward, and then we can just add that into the different parts of our ship, right? So I can say, let's say waypoint.x times the value, and I'm going to increase ship.x by that, right? And it's very symmetric for y, right? Really treating the waypoint like a vector, and then I'm just changing and multiplying the magnitude of that vector. Really cool kind of like math-based problem that we have for day 12. So this is looking pretty good. It should be calc, and by the end, I'll just return my ship. And like before, I think we still want to actually return the sum of the x and y component. It's something I forgot to do for sure because I see that this line 48 is dimmed out. I definitely need to be calling my degree to radians. So let me actually convert that stuff over here. So maybe I'll say, I don't know, const angle equals degree to radians of the value. Cool. And then sometimes I negate it, sometimes I don't. So maybe I'll say over here, this will be the plain old angle, but then this one should be the negative angle. So that means now we're ready to put this all together. I can say const, we'll get the x and y from this. So remember that calc just returns my ship, so the x and y coordinate of it. So I'll do equals calc of my commands, all of the commands, including the directional ones as well as the rotational ones. And then like before, return math.abs of x plus math.abs of y, giving me the Manhattan distance, or like the grid distance. So if this is working, then I should get the result of 52,203. So let's give this a shot. So I'm getting a little error here. It says angle is not defined. Let's debug that one together. So where's my angle? So I create angle here, but I didn't do it on this side. So maybe I'll just call it twice. Shouldn't be a big deal. Let's try that again. Nice, so it looks like I'm super close here. This is really just a matter of some floating point arithmetic for my particular solution because I'm using like math.cosine stuff. So notice how this is super duper close. The thing about these like floating point operations like cosine and sine, they won't give you the flat number just because of how arithmetic kind of works in programming languages, right? So I think I'd be okay just to round this, see how like minutely, kind of off the actual number is. It has a bunch of zeros, which I know mathematically means if I have like the same digit appearing like more than twice, then I know it repeats infinitely. So I should basically ignore this 6. I think to me, it's as simple as just rounding this stuff. So I could round over here in my kind of final answer just to make sure things don't get too out of whack. I'd rather correct all of those rounding errors as we actually calculate them, right? So I think the move would be, I'd rather round every time we rotate a point. I know that this function is the cause of those like approximation errors. So maybe over here, we'll say math.round. So that should be good. And then we should get some nice square answers. Awesome. So there we have day 12. It's a really interesting problem. I actually had quite a blast working on this one. It's really one of those problems that you definitely want to draw out. So I was kind of drawing a lot of pictures on like my whiteboard to figure out how to make sense of this one. And I was kind of glad that I actually got to use some math, which I am a fan of. So I'll catch you tomorrow for day 12.